Exercise 8.2, first question. It is given ABCD is a quadrilateral and P is midpoint of side AB, Q is midpoint of side BC, R is midpoint of side DC, and S is midpoints of side AD. And the first part is to prove this SR is parallel to diagonal AC, and also SR is half of in length SR is half of AC. That is the first part. So first we will write what is given. It is given ABCD is a quadrilateral, whatever is in the question. ABCD is a quadrilateral, P, Q, R, S are midpoints of the sides respectively. And first part is to prove SR is parallel to AC, and also SR is half of AC in length. Now we will take out triangle ACD. I'll just to make it easier, I'll draw here separately. Which triangle ACD I'll take out separately is like this. ACD, and the midpoints here. S is midpoint here, R is midpoint here. So in this triangle ACD, what do we have given? S is midpoint of AD and R is midpoint of CD. Therefore, by midpoint theorem, what we can say? SR is parallel to AC, and also SR is equal to half of AC. So this first part is proved by midpoint theorem itself. Second part is to prove this SR is equal to PQ in length. So already we have proved in the first part this triangle. In triangle ACD, what we have proved? S is midpoint of AD and R is midpoint of BC. We have already proved in the first part S is midpoint of AD and R is midpoint of DC, and this implies SR parallel to AC, and also SR is equal to half of AC by midpoint theorem. You will mention here by midpoint theorem. Same way you will see in the triangle ACB, the other triangle ACB. In triangle ACB, what do we have? P is midpoint of AB. P is midpoint of AB. Q is midpoint of BC. Therefore, by midpoint theorem, again, by midpoint theorem, what we can say? PQ is parallel to AC. PQ parallel to AC, and PQ is equal to half of AC. We can mark it, say, equation 1, mark it equation 2. So you see here, what we have proved? We have proved this SR is half of AC, it is here, and PQ also half of AC. So we can just write together again, SR is half of AC, and here you got again PQ is also half of AC. So from this to what we can say? Right side equal, so LHS also equal. That means SR is equal to PQ, and this is the proof for the second part. Third part is to prove PQRS is a parallelogram. To prove PQRS is a parallelogram. See, we have already proved here SR is parallel to AC. SR parallel to AC. We have already proved in equation 1. From 1, we can just mention here equation 1 and 2. From equation 1 and 2, what we have got? SR parallel to AC, and also you got here PQ parallel to AC. PQ parallel to AC. So what does it imply? SR is parallel to AC, PQ also parallel to AC. See, right side same, so SR must be parallel to PQ. And also we have proved here you see SR is equal to PQ. SR equal to PQ. So what we have got, you see, we are in this diagram, we are getting SR parallel to PQ here, and also we got SR is equal to PQ here. That means in this triangle, in quadrilateral PQRS, you are getting one pair, this pair, one pair of sides, opposite sides are parallel and equal. In quadrilateral, you can mention here, in quadrilateral PQRS, we got one pair of opposite sides are parallel and also equal. That is PQ and SR, they are parallel and also equal, and therefore PQRS is a parallelogram, because there is a theory, a quadrilateral with one pair of opposite sides parallel and equal is a parallelogram, and this is the complete proof for the question.